The most common technique for strengthening a columnar transposition is to make some of the rows different lengths. This makes it harder for Emily to know where the strips should begin and end. 4 such ideas are shown. Of these, number 4 is the strongest, since it disrupts the strips at an unpredictable point in the middle, rather than at the ends. More elaborate patterns of blanks could have 2 or more blanks in some columns. Columnar transposition with these variations is rated 4, provided that Emily does not know the pattern. The rating goes up to 5 for variant 4 if the key is long, and there are a variable number of blanks in the columns. The French used a system like this toward the end of World War I. It is believed that the Germans were able to read at least some of those messages, largely because the French reused their keys many times. 2 further variations on number 3, the staircase, are 5. Start from column 1 when you reach the right edge, making a skew pattern, and 6. Reverse direction when you reach the right edge, creating a chevron or zigzag pattern. The advantage of these patterns is that the number of characters is the same on every row except possibly the last, making it very easy for Reaver to calculate the number of rows. Here are examples of these 2 variations. You can also have 2 or more separate staircases of different widths, or have staircases in both the diagonal and anti-diagonal directions, / and /. When you are deciphering a message sent with any of these columnar transposition variants, if you have any difficulty calculating how many rows are needed, or how long the last row is, here's a trick. Count the letters in the message and fill in the array left to right with that number of little dots, following the same pattern that Sandra used to write in the letters. Then fill in the letters over the dots. For example, in variant 2, suppose you have agreed that you will always start with 7 letters on the first row. Ciphertext 2 has 38 letters, so you put 7 dots on the first row, 8 dots on the second row, until you have placed a total of 38 dots. Then you start filling in the letters in their proper columns, replacing the dots like this. Another way to use blacked-out squares is to fill them with nulls. The nulls should be chosen so they form uncommon letter pairs on both sides to make matching the columns harder for Emily. It is better to use common letters rather than rare letters, which might easily be recognized as nulls. Here is an example. Columnar transposition with nulls is rated 3. With a fixed pattern of blacked-out spaces, the rating is 4. Section 7.2.1. Chi-square. Historical tidbit. During World War II, the British used a variant of this idea called Chi-square, invented by Brigadier John H. Tiltman in 1941. Chi-square was a columnar transposition cipher with lots of blackouts. The British issued pads of 26 by 26 grids with about 60% of the squares blacked out in a random pattern. Each page had a different pattern. The message was written into the white squares going across the rows and then read out vertically in some order. The grid was square, so it could be used in any orientation. The key was the page number in the pad, the orientation, and the starting and ending positions within the grid. The cipher clerk would draw lines on the page to mark the message area. Using different areas allowed pages to be used for multiple messages. The drawback was the need to distribute so many pads. To minimize the number of pads, the British used each page for a full day, for perhaps as many as 50 messages. This meant writing faintly and erasing many times. The pages became unreadable, and eventually the cipher clerks refused to use them. Chi-square was abandoned in 1944. After the Germans captured some of these pads, along with the instructions, they started using the system themselves from 1944 until the end of the war. They called it Rasterschlüssel, meaning grid key. The Germans, however, did a poor job of selecting the black and white squares. They used too many adjacent white squares, so the British could identify bigrams and trigrams when they matched up the strips. These messages became a valuable source of intelligence for the British. Chi-square is rated 7. Rasterschlüssel is rated 4. It should be noted that in the computer era, the black and white squares could be transmitted as a pattern of bits. The grid could be any size, and the grid could be changed for every message. I suggest 65% to 75% black squares. Done this way, Chi-square would be rated 8. There is a simplified version of Chi-square for hand use that does not require printed grids, and that allows you to use a numeric key to specify which squares are blacked out. Here are two variations of the blackout transposition cipher, a left-right alternating version and a stair-step version. Both use the numeric key 3174255 for the blackouts. The blackout key can be a repeating key, or it could be generated by a pseudo-random number generator. You would use a separate key to specify the order for reading out the columns. Another method for strengthening columnar transposition is to break the text into blocks of irregular size. For instance, if the message length is 150, you could break it into blocks of 37, 71, and 42 letters. This method is rated 4. If you use a different key for each block, the rating increases to 5. Combining a columnar transposition with any type of substitution cipher greatly enhances its security. Even combined with a simple substitution, the rating increases to 5 because matching the strips is much harder. It makes no difference which one is done first. Combining a general polyalphabetic cipher with a columnar transposition of at least 12 columns increases the rating to 7, even if the period of the polyalphabetic is as little as 3. This is because you have essentially removed the possibility of matching the strips. Section 7.2.2 Word transposition. Word transposition is a historically important columnar transposition based on words rather than letters. It is the main method used by the Union Army during the American Civil War. The idea came from Anson Stager, a Union telegrapher who later founded the Western Union Telegraph Company. Union Army communications were hampered by a high rate of transmission errors. In many cases, commanding officers would forego the telegraph and simply send a messenger on foot or horseback. Stager realized that sending words instead of individual letters would cut the rate of errors and reduce the need for retransmitting the messages. Union cipher clerks wrote the messages word by word from left to right in a rectangular array, and then read them out using a variety of routes, such as alternately going up and down the columns, or alternately taking columns from the left and right halves of the array. Null words were used liberally. Here is an example. Notice that the third row is nulls. The columns are read out in the order 1, 3, 5, 2, 4.